course calendar. Someone was asking me when the project is due. I guess we're in prime time, right? Because I said project's due end of March. So I wrote down a week from Wednesday, but I'm also here that Thursday and Friday, right? So you could bring it in March 30th or even March 31st, and that's fine. What I hope will happen, though, is that I'll see you sometime within the next 2 weeks. That if you're having any kind of a challenge with the project, that you come in and get a little help. I always look forward to these weeks of working on, I don't know what I'm going to be answering in office hours, but it's something that you're interested in, you chose to work on, and maybe I can help you out with it. Okay. You'll also notice there's not much homework listed yet for Chapter 15, although I guess I just published the homework for Sections 3 and 4. Okay. And I'll get the rest of these up, but no one seems to be in that much of a hurry to work ahead, so we're okay. We've got enough to do. All right. Exam on Chapter 15 is not going to happen until April 10th, okay? So you can kind of pace yourself. You know where we're at. Okay. So let's look at a few things here. Maybe right now we should look at the group work, okay? And so, yeah, I mean, x equals y squared is a sideways parabola, and this you can write as y equals x, I guess it'd be negative x plus 2 would be slope-intercept form, right? So if you want to graph it, we know it goes through 0, 2, it goes through 1, 1, it goes through 2, 0, right? And we can go from there. I mean, this is an easy line. And of course, the sideways parabola, I'll use a different color for that. Maybe I'll use pink for that. So this x equals y squared goes through 0, 0. Oh, it goes through 1, 1. So that's kind of nice. You already know one of the points of intersection. And it's this parabola, right? And some of you were able to figure out the other point of intersection over here, which is what?
4, -2.
4, -2. Okay. And again, I tried to make it easy enough that you could even get it by plotting points like I just did. But of course, you know the homework's not going to be like that. The homework, they're going to be talking about some region R bounded by the curves, right? So R is this region in here. And part of the trick is going to be to find these points of intersection. So how do you do that? Well, algebra, let me give you just an example of the kind of algebra you might use, right? If we know that x equals y squared, and we also know that, if I write it this way, x is 2 minus y, let's say. I'll write it that way. Well, then you can set y squared equal to 2 minus y. And how would you solve that then? Probably like that. And then what? Quadratic formula, right? Or if you're really lucky, like we are here, and people said this one wasn't nice. This was nice, right? I mean, there's your y equals -2 coming right from there, right? And there's your y equals 1. And once you have the y values, how do you get the x values? Well, plug into either one of the equations, right? You could square them. That's one way to go. You guys follow so far? So again, this is the kind of thing you'll do with undoubtedly worse numbers than what I gave you just now. Okay? And so you'll want to sketch the region R. And then I said, compute this as an iterated integral, first integrating with respect to x. Okay, so that means we want to rewrite the integral dA with dx on the inside and then dy on the outside. And when you see this, okay, the outside, we want y values, right? We're going to put numbers here and here. What y values do we want? Well, you could see here the lines that bound the region come from the y values you got here, y equals -2 and y equals +1. I mean, there's a reason that I said let's compute those points. So that's what goes here and here. right? And then the inner ones, we explained this to some people, those have to be functions where x is a function of y. And so I would write, again, it's top minus bottom. Well, notice I did right minus left. I was explaining this to some of the groups. So we have the top, I guess, of this thing is the line. So it would be 2 minus y goes here. And it would be y squared goes there. And then we have what goes in here, I guess, is 6x plus 2y squared. And I only think I want to do one more step. Ryan, question?
Yeah, scroll for a second.
Sure.
The x plus y equals 2. How did you get that? Scroll for a second. How did you get that to be? Oh, that's negative x right there. Okay, I just saw the equal sign.
Oh, yeah.
That's okay.
It was y equals negative x plus 2. Yeah.
Okay.
Thanks. So I guess I'll do one step and then I'll just say, hey, the rest you can handle. So we ignore the dy stuff. We're just working on the dx. When I integrate this dx, I get 3x squared. That's what the 6x becomes. And this we treat as a constant, so we're going to say plus 2y squared times x, right? And now what happens is you have x equals y squared, and you have x equals 2 minus y. And so you use the fundamental theorem, good old f of b minus f of a, right? I'm going to plug a 2 minus y in everywhere there's an x. Oh, that algebra gets a little bit dicey. And I'll plug in a y squared everywhere I see an x. But in the end, I'll have some big, ugly polynomial in y that I can integrate dy. And maybe we'll show one of your attempts up here in a moment.
Do you have the answers?
Not yet. Do you guys have the answers?
What did you guys get?
Below.
All right, so let's see. So let's plug in and see what this looks like. We still have negative 2 to 1. We still have the dy, but I realize I'm going to need some room. So here I go. I have 3 times the quantity 2 minus y squared plus 2y squared times 2 minus y, right? That's the f of b, if you want, minus 3y squared is squared, minus 2y to the 4th, right? Because I plugged in a y squared next to the other y squared. The minus is because I'm really subtracting the whole thing. Questions so far? Moving on. Let's see. Would I treat it as 2 integrals? I might. I think I will. Well, nah, let's distribute. Here we go. Negative 2 to 1. Oh, it's tempting, though. Okay, let's do it just for the sake of showing off. 3 times 2 minus y quantity squared dy. This is a piece of the integral, right? It's just the first term. And then the rest of it, I'll actually do a little bit more simplifying. So plus the integral from negative 2 to 1. Let's see. I could distribute that 2y squared and I get 4y squared minus 2y cubed from that other blue piece minus, now I'm counting 3y to the 4th and 2 more y to the 4th is minus 5y to the 4th dy. How many are with me so far? Okay. And why did I treat them separately? I think the brown one's easier. The blue one, what I'm thinking of doing is a substitution. What do you think I'm going to substitute? If u equals 2 minus y, what does du equal? Negative dy. And so I can do that, and then basically what I would be doing is integrating negative, because I need the negative to get the negative dy. Wouldn't it be negative 3u squared du? Isn't that right? So I'm not going to write that all out. I'm just going to integrate it. Because if you integrate negative 3u squared du, what do you get? Negative u cubed, yeah. So I claim that this blue thing, from all that work in green I just did, we can write as, let's see, negative 2 minus y cubed as y goes from negative 2 to 1. Does that make sense to people? Now the other bit, let's see what happens. Okay, so here's where your fractions show up, right? You get 4/3 y cubed. And here's y to the 4th over 4, so minus 1/2 y to the 4th. Oh, this one works out nice. Minus y to the 5th. And again, all that stuff is also from negative 2 to 1. So now it's just a matter of plugging in 1s and negative 2s. All right? I'm getting to the point where it is what it is. All right. Hey, plugging in a 1 is nice. Right? I just get 1, negative 1. So the green part, I guess I'm running out of room. I'll kind of move up here, guys. We have negative 1 minus, now what happens when I plug in negative 2? 2 minus negative 2 is 4. 4 cubed is 64, but there's a minus there. So minus 64. So we're actually just going to add 64. Does that look right? I think so. And now I'll try the browns. Plugging in 1 works out really nicely. 4/3 minus 1/2 minus 1. And now when I plug in negative 2, let's see. Negative 2 cubed is negative 8, so I'm getting minus 32/3. Negative 2 to the 4th power is positive 16. Divided by 2 is positive 8, so negative 8. Oh, time out. I'm subtracting that. That's going to be positive 8, isn't it? And it's going to be, because I'm subtracting when I plug in negative 2, so you're right. Thank you, Alex. We're going to add the 32/3, aren't we? Mm-hmm. Yes, I agree. We're going to add those 32/3. Let's see about here. When I plug in negative 2 to the 5th power is negative 32, but we have a minus, makes it positive 32, but I'm subtracting, so I get minus 32. So if, thanks to Alex, we did it right, we've got some nice numbers now, right? Because look, we have 64 minus 32 is what? 32 plus 8. All that blue stuff adds up to 40. And then the 32/3 plus 4 more thirds is plus 36/3, which is what? 12. And then I just need to subtract the stuff I didn't account for yet. There was a minus 1 and a minus 1 and a minus 1/2. Isn't that minus 2.5? Right? So 40 plus 12 is 52 minus 2.5. I'm getting 49.5. Did anyone else get that? We have a couple of agreement. Wow, that was fun. Now the challenge is, can we do it again by first integrating with respect to y? I remember when I first learned this, I always wanted to integrate first with respect to y because I liked y as functions of x. I didn't like sideways parabolas. And then I got over it, and I want you to get over it. So here we go. You know, if we draw the same region R, the issue, so I guess I changed colors. This time the line's pink. All right, sorry guys. Hope you can deal with that. The issue is, see, you're going to be integrating first with respect to y, and we're going to finish then integrating with respect to what? So let's write it this way. dy dx, let's fill in the 6x plus 2y squared. But I guess what I want to emphasize here is that you're going to finish integrating dx, which means we're going to be moving from this line to that line. This line would be x equals what? Well, I know that point of the parabola. 0, right? Because that's the point 0, 0, I remember. I also remember this is the point 1, 1. Right? But see, we have an issue. The issue is something changes when you get where? Here. Because remember we talked about top minus bottom? Over here, to the right of that yellow line, top minus bottom is going to be line minus curve. But over on the left, right? Actually, in Calc 1, you would have cringed. You would have said, oh, it's not even a function of x. Although you know you can express this as two functions of x, right? And so this is where I said we're going to integrate separately over each region, okay? And then add them. So again, this is what I'm thinking about, but it doesn't quite work. The region R can be split up into an R1 and an R2 by this line. So this region in here I'll call R1, and this region in here I'll call R2. Okay? And let's work it out. So if we have the first region, R1, so let's see, 6x plus 2y squared dy, we're going to be integrating from x equals 0, because this is the outer one, x equals 0 to x equals what? 1. Those are the outside boundaries. This line here, x equals 1, comes into play. Remember, this is the point we found was 4, negative 2. So plus, we're going to have a double integral starting at 1 and ending at what? 4. It's the x values, right? X equals 4. And I guess what's different is that here you're going from green parabola curve and green parabola curve, whereas over here it's green parabola curve and pink line. What line is that? I guess I don't have it written here anymore. What was it? Wasn't it y equals negative x plus 2?
Yeah.
Wasn't that it?
Yeah.
Okay. So in the second integral, I can tell you that the top would be negative x plus 2. What about the bottom for the second integral? The negative square root of x is correct, right? Because we understand that this parabola, which I wrote as x equals y squared, when I solve for y, I have to take the square root of both sides, but I have to put plus or minus the square root of x. And then you kind of have to ask yourself, well, see up here would be the positive, but that's not really involved right now. It's the negative square root of x that we go right here. And for region 1, all you have to do is integrate from what to what? Negative square root of x to positive square root of x. Yeah. Okay? Guys follow so far? And I'm going to point out one more thing that Ryan noticed when he was doing this. He noticed that in region 1, there's some nice symmetry, right? I have to be careful here, though.
I thought
Be-
in Calc 1, or Calc 2, I would use symmetry for that and just do double from 0 to square root of x.
Right.
But
Right.
I don't know how that works for this.
I guess the issue is 6x plus 2y squared. Will that behave the same here and here? I think it will. I think it will, because the x values match up and the y's being squared. I think you're okay to do that. So what Ryan did with this integral was he said, okay, this is going to be 2 times the integral from 0 to 1, the integral from 0 to square root of x, 6x plus 2y squared dy dx. That's kind of a nice shortcut because now you get zeros down here. Okay? But it definitely won't work here, right? We don't have that kind of symmetry. The second integral, you're just going to have to work it out like we did on the front. Okay? And for the sake of time, I'm going to stop and say, hey, when we add, we get 49.5. Okay? And we could check that. Maybe during the break, I'll punch it into Wolfram Alpha or something and see if I can get that up and running for you. Integral calc might get it for us also. Do you guys have any questions? All right, let's take a break and come back at 11:13, and we'll